Okay, so for today's assignment for calculating momentum, the first part has got some pictures at the top, and it says consider the pair of objects and circle the one with more momentum. So when you look at this, you notice in the first one they have the same velocity. So if they have the same velocity, then the object with the more mass is going to have the more momentum. In this third example, you'll notice that they have the same mass. So in that case, you would go with the one that had more momentum. As you move through, there's a couple of them that have different masses and momentum, so you may have to actually calculate using momentum equals mass times velocity. Try to guess based on the sizes and then calculate and double check to see if you're correct. Okay, and then for the second part of the worksheet for today, or the practice problems, we're just going to be calculating straight up momentum. So in this case, we're going to be using this momentum equals mass times velocity. So this is the mass here and the velocity here. So we're going to say 185 kilograms times 75 meters per second. And then let me grab a calculator because I can't do that one in my head. 185 times 75 equals 13,875 kilograms times meters per second. Remember, you have to keep the whole thing. Keep in mind this triangle as you're working. So you have momentum equals mass times velocity. So if you're looking for momentum, it's mass times velocity. If you're looking for mass, it's going to be momentum over velocity. And if you're looking for velocity, it's going to be momentum over mass. So that's basically how you're going to do those. All right, move to the last part of today, and we're doing the inelastic collision. So we're going to be using this formula here. So you need conservation of momentum. So initial momentum has to equal final momentum. So we're going to set this one up with mass of 1. So that's 1,200 kilograms times 2 meters per second. That'll be my first part of the equation. And then it hits another car that is parked with a mass of. So then that's going to be 1,000 kilograms times 0 meters per second. And then that's going to equal, we got to combine the masses. So that's going to be 1,200 kilograms plus 1,000 kilograms, right? And then times final velocity, which is what we're trying to figure out. So we're going to say 1,200 times 2, and we're going to get 2,400 kilograms times meters per second. This one will obviously be 0 because anything times 0 is 0. And this will be 2,200, right, kilograms times final velocity. So then that'll give us 2,400 kilograms times meters per second equals 2,200 kilograms times final velocity. And divide both sides by 2,200 kilograms. Okay, so 2,400 divided by 2,200 gives us 1.09, and then kilograms cancel, so that would be meters per second. So that's going to be our final answer. All right, so go ahead and work through this one, and then try to work through number 8 as well.